Hello and welcome to the third episode of Altitude, our behind-the-scenes look at the dark arts of air traffic control and the people who make it all work. I'm your host and Heathrow Air Traffic Controller, Ady Dolan. So far in Altitude, we've looked at future ATC technology and amazing stuff like satellite navigation across the Atlantic, down to a few meters. But today we're going to jump in the DeLorean and head back in time. We've got a belter of a show for you, going right back to the very origins of air traffic control and how it emerged after the First World War, and some of the incredible characters that helped create it and the legacy that they've left behind for us guys. Now, it may surprise you to hear that the epicenter of this technological crucible was, in fact, Croydon. For those who don't know it, Croydon is in southwest London. It's a beautiful part of the world. And there's no one better to help us navigate through that story than Ian Walker, who, as well as being an airline pilot, is the chair of the Historic Croydon Airport Trust. Hello, Ian.
Hi, Ady. How are you?
I'm very well, thank you. We'll be talking to Ian to find out why Croydon was such an important location for early commercial aviation. I'm also delighted to have with me my esteemed Heathrow colleague, Adam Spink, who, as well as keeping the aircraft safely apart at Heathrow, does a cracking job of getting them very close together at the Royal International Air Tattoo at Fairford. And he's also a very keen aviation enthusiast and historian. Hello, Adam.
Hey, good to see you again.
I'm looking forward to hearing Adam's perspective on how the skills we use today have evolved over the past 100 years and what might happen in the future. As ever, we're open to your questions and we'll try and get through as many as we can at the end of the show. Hopefully you've got a little Q&A box on your screen. Pop your question in there and we'll try and get through that at the end. So, Ian, let's start at the beginning. Paint us a picture of commercial aviation at the end of the First World War. Where were we?
So the First World War, really big developments, and that was really, really important for making commercial aviation happen as we know it today. So huge developments in aircraft technology, engine technology, and the size of aircraft. Radio has made huge leaps, and that's really, really important for air traffic control. Also, there's the recognition that you're going to need some sort of legislation to make this work. There's the real prospect now that aviation can be used on a commercial basis and it will involve flying to other countries. So you needed a framework to do that. So in 1919, running alongside the Peace Conference, a little known part of really important legislation happened, and that was the Convention for the Regulation of Aerial Navigation. So that's where we get the first rules, and that really set out the base principles of how we can do air travel today. Airports, certificates of airworthiness, licensing. Also, the aircraft, if they've got more than 10, can carry more than 10 people, then they have to have a radio. And we've seen some of that legislation start there that makes air traffic control possible and air travel possible.
And at this stage, where are we based? What's the main focus for aviation in the southeast?
So in the southeast, sort of London's airport, and this is actually Britain's airport. Initially, it's Hounslow Heath. So we probably saw a couple of years ago that big anniversary of the first commercial scheduled flight, 25th of August 1990 from Hounslow Heath. That's originally where Britain's airport was. There was another diversion airfield down on the Kent coast at Lymm, but they were Britain's two government public airfields. That was it.
Wow.
But all the operations moved from Hounslow Heath down to Croydon in March 1920. Reasons for that being is the RAF had just vacated the airfield at Croydon. It was bigger, slightly better equipped, better weather, and it's actually half an hour nearer your destination because your two routes at the time were Paris and Brussels. So that was it. So very limited opportunities, but even so at the time, really groundbreaking.
So who was flying at this stage then, Ian? Who were the passengers?
So the people generally who are flying at the time, they're very wealthy. It's not cheap to go flying. So, you know, a return ticket to Paris was £44. Your average skilled worker, like a plumber, would earn £12 a month. Government officials, celebrities, businessmen, they're generally the people who are flying. So other people can't really afford it at the time. So that's your passenger type.
Wow. And Adam, who's actually at the controls of the aircraft at this stage?
Yeah, a lot of the pilots were obviously veterans from the.
Oh, Adam, we're just struggling to hear you there. It's a little bit faint.
Ady, not any better.
That's slightly better.
So yeah, a lot of the pilots will be former World War One pilots from the World War Air Service, which obviously then became the RAF on the 1st of April. As will actually a lot of the aircraft they were flying.
Adam, if I could just ask you to put your mic down.
Yeah, okay.
How's that?
I'll switch to my headset mic.
There you go.
If you might want to talk to Ian for while I sort this out, and I'll.
No problem. So Ian, talk to us about the state of air traffic control after the First World War. Presumably, we've got a lot of aeroplanes starting to be generated, and we want them not to bump into each other. I guess that's the basic premise, is it?
That's the base principle. I mean, very simply as well, is after the war, you've got thousands of DMOD pilots, so they put some regulations in place just to make sure that people weren't going and doing their own thing. So they made sure there's things like licensing. But you are starting to get some regulation. Air traffic control per se, as we recognise it today, it didn't exist. But you are seeing those first stepping stones towards it, those really important building blocks to make it happen. There's a recognition that radio is going to be really, really important for aircraft. The simple fact is that you can communicate with something that's a moving target, which was fairly revolutionary at the time. And it was actually known as wireless, because you didn't have to have a wire connected to the communication source. But we are starting to see some regulations come in place. So even though we got those regulations in 1919, they didn't actually come into force until 1922. So in the interim, you've got countries doing their own thing or not. So Britain really was sort of all over this. And the Air Ministry are promulgating sort of procedures. In 1920, they come up with procedures for route aerial traffic control by radio telephony. So using radio to communicate with aircraft, do position reporting, how those procedures should be carried out, giving the outline of the call-up procedures as well, which weren't actually in the international regulation. So this is national legislation to make that happen. And then from there as well, we're starting to see some big steps as well with the structures you actually need for air traffic control that we recognise today. So probably one of the big ones that's instantly recognisable is the air traffic control tower. So a massive step. So you did have radio offices. Every airfield needed a radio office to house all the radio equipment, which was absolutely massive. So if you imagine, your kitchen worktop, full of things big as, bigger than microwaves, a whole row of those. That's what a radio was like in the day. But what they're doing is they're moving from that and they're looking at a structure that can control airfield operations. So at Croydon, on the 25th of February 1920, the Air Ministry set out specification for that, and it was a timber hut on 15-foot stilts with a platform all the way around it, and it had a windownometer in it. And they said it should have windows all the way around, so you can see all the way around.
Apparently, it does help in control towers to have more windows than walls.
Really, really obvious, but that was a big step, and it was a real move away from what anyone else was doing. And not every nation immediately leapt onto that as a concept. So we were really very much at the forefront of developing sort of the basic structure of air traffic control and how it works, and putting those systems in place as well. So that's one part of it.
So Adam, we were talking about pilots, and we love our pilots, but who was flying the aircraft back in those days?
Yeah, you wouldn't think an air traffic controller would have radio problems, would you? But it's all fixed now. As I was saying, a lot of the pilots would be former World War One pilots. The armistice is signed, and they've only been trained to fly airplanes and not much else. So there's plenty of trained pilots around, plenty of aircraft around as well that are very cheap. So things like Vickers Vimy, the DH9, Handley Page, Typo, they're all former bombers or reconnaissance aircraft that were used in the closing stages of World War One, and they're plentiful in supply, and a lot of them were converted to carry either mail, letters and parcels, or passengers, and that's how a lot of the aviation started after the First World War.
Amazing. And some of the procedures, Ian, I mean, I remember back in the college 20 years ago, we were just still thinking about signal lamps, and they were just kind of being obscure and being obsolete. And I guess that stuff was at the forefront of technology, lamps and flags and stuff like that.
Absolutely. That was the primary method of communication. So it was all based on visual signalling. And one of the main reasons for that is, even though they're recognising that radio has a place, it is very, very early days of radio technology. The radios are, in some respects, they're there's reliability issues, but more than that, the big restrictions on them is that the actual aerial technology was really, really basic. So it was a wire that they used to trail out the back of the aircraft to about 100 meters maybe, and that would trail out the back of the aircraft. So obviously if you're taking off and landing, that's a bit of a hazard. Not ideal, doesn't help your takeoff run, shortens your landing run. The other thing as well is, of course, is that the houses in the local vicinity as well, you're going to start being a hazard to them. And you used to get lots of complaints around Croydon of aerials being wrapped around people's chimney pots or taking chimney pots. So you couldn't actually use them on the ground. An aircraft radio you couldn't use on the ground. And the other aspect of it as well, they actually had the electricity supply was actually a wind-driven generator. So the aircraft actually had to be in flight for the turbine to generate power.
And what about the actual the beacons at the airfield? How could you spot an airfield from the air?
Well, for at the time, it was quite advanced, but in simple terms, it was an acetylene-powered gas burner, a massive beacon. So the one at Croydon was like a giant cone. Looks a bit like a giant version of a Cluedo piece, but it was about 20 feet tall, burnt acetylene gas. It had something called a sun valve, which would sense sunrise and sunset, and they would automatically run for 2 hours after sunset, burning acetylene gas. So, and it would actually just launch this really piercing beam, straight upwards through the clouds. It could be seen for a long way away. So that's one of the main navigation aids they've got at the time. So that's really the start of the term beacon as well. It was literally a light beacon, and then you move on to radio beacons. So
I can't really see a gas-powered beacon being utilised today under our safety regulations next to a runway at an international airport. We should put that forwards.
Yeah, back in the day. So it was very rudimentary. We're talking
Fantastic.
about biplane airliners, piston powered, open cockpits, so it's all that sort of big all stuff. So that's what it was like at the time.
So with all these major technological advances that we've had in all areas of our lives, there's always a few key individuals who drive those big changes. So tell us about some of the characters, Ian, that were about in those early days, and what tools did they have at their disposal?
So probably for Britain and globally as well, one of the really important people on the radio development front was Marconi. So he had a UK base, very important in developing radio during World War One. You move from sort of old technology, spark gaps, so literally creating a spark to send a radio signal to a continuous wave. So that all that technology is there, and many of the people who are working that in World War One to develop for military purposes, and now working on the civil side and developing it and using it in a civil manner to actually use the principles of radio propagation to help navigate. So one of the key people at Croydon was a chap called the radio officer there called Fred Stanley Motford. So he had experience during World War One actually installing aircraft radios, and he had a lot of experience in that area, and also training pilots on how to use air-to-ground operations. So he's working at Croydon, operating the radios there, but also looking to develop a position fixing system using radio. So one of the basic systems are using a goniometer to actually get a bearing. So that's really important. But of course, one of the things they understood, if you had another station somewhere and you're picking up a radio transmission from an aircraft, you can now cross-cut the positions. You can get a position fix. And that was really, really important because at the time, the only way of navigating for pilots was visually. So if you've got poor weather, low cloud, fog, you can't see the ground. So that's a real problem for navigation. So this is really where radio really did start to come into its own and became really, really important, because we start seeing that being used for radio navigation, which is the basis for all navigation for aircraft today. So Motford was really important in developing the radio position fixing system at Croydon. At the time it was called wireless position finding, but we call radio position fixing now. And he also went on to look at some of the issues with actually using radio telephony, so moving from Morse code to using speech over radio, and the problems with that as well, and being understood. So we start seeing the use of phonetic alphabet. And one of the things that he was charged with doing by the Air Ministry was coming up with an equivalent phrase of SOS. because there wasn't an equivalent phrase for radiotelephony. So if an aircraft was in distress, they were supposed to say SOS, because that was the only promulgated procedure. But he came up with mayday. So that's where we get the mayday distress call as the RT equivalent. And he took his inspiration from the French mayday. That's really poor French, and I'm sure people who speak French will be on the phone to you about that. But it means help me. So there was a lot of French pilots, a lot of Belgian pilots, and he used the inspiration from that to come up with this word in aviation that could not be confused with anything else, because it's completely unrelated to visibility, speed, height, or anything else. You know, it's a completely unaviation type term. So that's how mayday came about in 1923.
So that was Fred Mockford at Croydon came up with mayday.
Came up with the mayday distress call.
Brilliant.
So you know, and that's, you know, we're still using it today. So really important in saving lives.
Hopefully not too often, Ian. But you mentioned the phonetic alphabet there, and obviously we go back, and if you look at the history books, Adam, there's lots of different letters and words used for different things. And how did that all develop, and how did it get to the point where we've got this universally acknowledged system that we've got today?
Yeah, I mean, it all started, again, as we've been discussing, in the 1920s after the First World War. As we've discussed, radios and the use of radio in aviation was becoming more widespread. So most nations around the world where aviation was growing dictated their own individual phonetic alphabets using words in their own language sometimes. And I know certainly the UK came up with their own in the 20s, and some of the words that we might recognise, but some completely alien to pilots and controllers today. And I think they had zebra and monkey and George and uncle. But I think as we get into the 1930s, ICANN, which organisation which is considered the precursor to ICAO that we have today, and Ian's already referred to, I think they certainly tried to standardise across the world in terms of the language or the phonetic alphabet that the pilots and ground staff will use. And I think the first version that they tried to come up with was actually based on cities of the world. Oh. So I know there was Oslo, Tripoli, Jerusalem were all representing those letters. So J was Jerusalem and O was Oslo. But then, of course, as we go on through the decades, we have the Second World War, where a lot of countries are working together, and certainly the UK and the USA then started to develop what we know today as the modern phonetic alphabet, with Alpha, Bravo, Charlie, Delta, etc. There's a lot of science actually goes in behind choosing which word is suitable, and Ady and Ian and myself will all be aware of why we don't say the words yes or no on the radio, because they're both one syllable and they could be obscured by interference, and it's very dangerous if it's misunderstood. So the science behind the actual words we use on the radio is very key to safety.
Absolutely, yeah, and you mentioned safety there, Adam, and what parallels do you see with those early days and what we do now? I guess even though they were at the forefront of technology, they're trying to come up with a system that is safe and is workable, and it's what we're still trying to do today with the current procedures that we have and new technologies that we bring in. The first thing that we think about is, can this be as safe as we can possibly make it?
Oh yeah, definitely. And even in that word I used before, standardization, it's all very well for us in Heathrow or in the UK to come up with a fantastic idea and introduce it, but if none of the other countries around the world introduce it, or none of the other airports around the UK introduce it at the same time in a similar way using similar language, Ian and his colleagues who are flying around from one airport to another and one country to another, it's going to be confusing. They're going to have to revise every time they fly to a new airport, which is obviously not ideal. So that word standardization is a very important word in aviation, even more so today than it was in the 1930s and 20s.
And just very quickly, Ian, I just want to mention one person who I believe is air traffic control license number 1.
Absolutely, yeah. GJH, Jimmy Jeffs. So really important for air traffic control. He started working at Croydon in 1922, and he did an enormous amount to develop the procedures that you guys are using today. So he went on to establish sort of the first air traffic control training school in 1938. So he was working at Croydon for his first decade of his career. He worked as a controller through the Second World War as well, helped set up the North Atlantic tracks as well in those routes, and was much decorated as well, CVO, OBE, and he eventually ended his career as Commandant at Heathrow Airport as well. But yeah, he's got ATC license number 1, which was sort of dated 1922. So we actually have that in the museum down at Croydon as well. So you can come and see that yellow book. So I think they're still yellow. Is that correct?
Oh yeah, absolutely. Little yellow book, absolutely.
The yellow panel. Yeah.
Come down and see the first one.
So we head towards World War II, and talk to us, Ian, briefly about the importance of Croydon at that stage, World War II through to D-Day, and then the Berlin airlift.
So Croydon was the Heathrow of its day. So in the interwar period, it was extraordinarily important. It was sort of airport central for Britain. And we have to sort of get the context of the time as well. You know, air travel is a completely new concept. Pre-World War One, we haven't done it on a mass scale or a commercial scale. So it's all new. Everything about it is having to be built and constructed and planned and organised. So Croydon was really, really important. You had the new terminal going in 1928. It was the UK's busiest airport, and it was one of the busiest airports in the world. I think it sort of quickly overtook Paris, and really it was vying between Croydon and Berlin for sort of the world's busiest airport. But then coming up towards the Second World War, it ceased to be a commercial airport because they shipped all the air traffic out, the civil air traffic out, and moved it down to Bristol for safety reasons, because Croydon was within range of German fighters. So as you became RAF Croydon then, part of Fighter Command, so it was the Battle of Britain airfield. But also later on, halfway through the war as well, we see the advent of Transport Command. So Transport Command was had an operation here, and then post World War II, when you see the end of hostilities as well, that's when you start seeing the sort of Berlin airlift, and many other airports in the UK are being used as well. We are seeing, the common sight with DC-3s flying in and out of Croydon as well, just carrying all sorts of supplies and goods, because everything had to be airlifted in. So, lots of people might not know that history, that sort of what happened after the Second World War, that sort of Berlin as a city became cut off because it was in the Russian sector, and the only way to keep it afloat, sort of the Allied sections of that city, was actually to fly everything in. So that it wasn't just food as well, but it was actually flying coal in as well for power stations. Everything had to be flown in. So it was a huge task, and quite massive.
And certainly over the past 12 months, Adam, we've seen a totally different change in our operation from hundreds of thousands of people to the importance of cargo and goods and supplies. And Heathrow and other airfields around the UK have become major cargo centres of stuff that's being brought in that we vitally need. And it gives you a very, very small taste of what it must have been like in those days of just constantly aircraft coming in, unstocking, restocking, turning around. Is that what it was like?
Yeah, definitely. I mean, during the course of the Berlin airlift, we're probably talking about over 300,000 flights going into the 2 and then the 3 airports in Berlin. I think it was about 2.3 million tons of supplies they transported into Berlin. And of course, from an ATC point of view, actually, the Berlin airlift is really important, going back to basic principles like airspace design, missed approach procedures. All of these things were standardized and codified in the Berlin airlift. And, there was actually a really good example of this in August 1948, when the US Air Force commander of the whole Berlin airlift operation was actually airborne over Berlin, flying in from France, I believe. And the aircraft a few ahead of his in the sequence crashed on the runway. The one behind that tried to land and burst its tyres, trying to stop before it hit it. The one behind that had to veer off the side of the runway. And in the end, the commander, who was actually airborne at the time, said, right, everybody else who's waiting to land, fly back to France, because we can't cope with this. And after that, they designed effectively missed approach procedures. And so all the crew briefed on them. They had the equivalent of what we would now call the integrated aeronautical information package. So pilots would have all the flight procedures standardized and printed out before they arrived there. If they didn't land on the first attempt, they would follow a design procedure and then fly back to where they came from. They wouldn't even try and go around again because there wasn't enough room in the sequence to fit them in behind. So again, a lot of what we see as controllers and pilots today in terms of information management, flight procedures, all came about from the Berlin airlift and the need to standardize across different air arms, different countries, pilots, different languages being spoken in the air and on the ground. So that's a really key event in terms of airspace management.
And talking of airspace, Ian, I guess that the whole thing was just uncontrolled airspace back in the start, but we had to develop some kind of airways structure then.
Yeah, absolutely. So you did early on start to see some sort of plan on we need to organise this in some ways, but compared to nowadays, it was very, very rudimentary. So you had some routes which were quite broad in their use, going between France, Brussels, Paris, and Amsterdam. But it starts to become more defined as the traffic increases. And in Croydon in 1933, I think you see the first time you actually get something that's akin to controlled airspace. So when we get something that's similar to low visibility procedures today, so when we've got really poor visibility like fog, this was starting to become an issue, because up until that point, there was no real restriction on what a pilot could do. They could fly in any weather. And of course, that wasn't hazardous just for them and their passengers, it's hazardous for other aircraft as well. So a system was put in place in Croydon. We have the Croydon Control Zone. And then if the visibility was less than 1,000 metres and the cloud base was less than 1,000 feet, Croydon would control that control zone, and no aircraft would be allowed in or out without the permission of Croydon. And they used to allow one aircraft in at a time and one aircraft out. So that's the first time where we're starting to get something that we actually recognise as airspace and is controlled by the controllers at the airport. And then that starts building up from there. So that's when you can see prescribed routes. And we did start to get some of those in the early 20s, just a route which would be generally following a railway line, a reporting at a station or a town. But you are starting to get something that recognises a route.
So just racing through the jet age, supersonic travel, we'll park all that to one side and get to where we are now. In the last 20 years, well, Adam, the last 20 years of your career, what are the biggest changes that you've seen, certainly technologically, in the way that we work in ATC?
I think certainly for me, it's the increasing prevalence of tools, as we call them now, support tools that are aiding the controller in what they do. When Ady, you and I started at Heathrow at very much the same period, it was paper flight progress strips, a little strip of paper in a plastic holder, which are excellent at scraping ice off the windscreen of the car. In fact, I still have a few in the car. But no, each flight was represented by a strip of paper in these plastic coloured holders, and you would use the window and a pen and that strip of paper and a wooden board to move the strips around. Now we have ground radar, air radar pictures with support tools to tell us when aircraft are going or appear to be going through restricted areas, or to highlight where difficult areas are on the airfield. You've got electronic flight progress strips now, electronic systems. So rather than strips of paper, they're touch screens, electronic touch screens, which can link to flight plans and all the data that the aeronautical system has for each aircraft. And we're starting to look at, in the near future, systems which will have a level of artificial intelligence and machine learning to be able to tell a controller when certain procedures can be used, or when aircraft are the right distance away from the runway to allow the next one to land, to advise the approach controller how close behind each aircraft the next one can be. So it's just that incremental increase in sort of equipment level and sophistication.
Incredible. Where do you think it will go next, Adam? Do you think that we'll end up with artificial intelligence driven cyborgs running the control tower? I know that there's probably a few already on some of the watches at work, but do you think that's where we're heading towards?
Well, I didn't say that. That was Ady Dolan who said that. But no, I think you're in a way you're right. But I think it, in terms of, it'll be taking away some of the mundane tasks, the checking, the monitoring tasks that traditionally humans are not very good at in terms of human performance, that systems are far better at monitoring the health and performance of other systems leaving the human more capacity to be able to make those judgmental and experiential decisions.
Yeah, and just lastly from you, Ian, in your career, your early flying right up to now, and thinking way back to Marconi and those smart spark gap radios. I mean, your aircraft that you fly now is an Airbus 320 series. So, I mean, in terms of technological advance, fairly massive.
Yeah, absolutely. Yeah, it's fly-by-wire. It's got so much technology to help us do the job safely, which is what it's about, really. And a lot of that as well is integration with air traffic control as well. Now we've got, the communication at all levels is constantly being improved, and that means it always improves safety. And that's what the job's about. So, yeah, they're a long way from visual navigation, trying to bimble along, trying to follow railway lines in fog and stuff. When it's hailing and snowing and stuff. So it's a world apart.
Fantastic. Well, we're going to get some questions now. It's been a fantastic discussion. I've certainly enjoyed it and learned some really great stuff from Ian and Adam about the inspirational people who've gone before us and helped make it all happen. So we'll jump across some questions now. And our first question is from Anita from Heathrow. And she asks, so we'll ask this one to Adam. What are the three most important details that someone new to the aviation industry should know about airspace? Something about the past, the present, and what's coming in the future.
Gosh, that's a very wide-ranging question there. I think in terms of about the past, the past and the present, I think, are very much linked together. In terms of the current airspace structure and design that we have today, as we've discussed, is very much based on 1960s, 1950s, even further back. The routes that we see aircraft flying today are based on radio navigation beacons, which actually they don't really use anymore. And in fact, in many cases, those radio beacons no longer exist in those locations. But the airspace structure, the routes are all based on the past. And the present is very much focused on trying to be as efficient as possible within those constraints. So, top athletes talk about marginal gains, and if you take a tenth of a second off here and a tenth of a second off there, you'll get the gold medal. That's very much what we try and do today with today's airspace structure, is just find the little bit of efficiencies here and there to add up to hopefully make a significant difference. And I think in the future, what we will be looking at is trying to redesign the airspace to make it far more efficient, both in terms of environment, in terms of noise for people on the ground, and in terms of the actual operation of the aircraft. Excellent.
And Ian, this one's for you. It's talking about the unreliability of some of the aircraft that were flying around in the 20s. Not quite like the aircraft that we see today. Was there any kind of fire cover available at Croydon in the early 1920s?
There would have been fire cover. Not quite to the degree we have today, but there was fire cover. I mean, that sort of accident was rare, but the accident rate was higher than we have today. The aircraft were unreliable. We are talking, very much first generation airliners. So they're pushing the technology that they had to the absolute limit. So the engines, the reliability there, they're putting them under a lot of stress. So there were accidents, but I think looking at total numbers, surprisingly few, really.
Absolutely. We've got a question from David. Adam, will go to you for this. It's similar kind of theme, but with ATC at 100 years of development, what do you think the future holds for the next 100 years?
Yeah, that's a really good question. I think, as we've touched on in the last 30 minutes, that the last 20 years or so of our careers have seen quite a significant change. We've had the GNSS, or the GPS satellite navigation, is how most modern airliners navigate, and even most modern general aviation light aircraft. But we still have somebody can get in a Tiger Moth and fly and follow a road or follow a railway line and not talk to air traffic control, and not even have a radio on board potentially. So I think in the future, the difference between the very technological top end and the very basic lower end will just increasingly diverge. So potentially, you'll have uncrewed aircraft flying passengers maybe at some point, or certainly cargo, as we've even seen in the last year, flying hospital supplies around, with all sorts of technological systems. But you'll still probably have the person who wants to get on board a Tiger Moth and fly without talking to anybody, without any navigation systems on board. And I think it's down to us as controllers and the NSP to work out how we can reconcile the two different use cases there and all that spectrum in between. That's going to be a really difficult challenge.
Absolutely. So going all the way back to Croydon, Ian, we've had lots of questions today about what still remains at Croydon. Is there anything that we can look at and see of the original airfield and the buildings that were there?
Yeah, absolutely. So we have got the sort of Britain's first airport tower. So airport terminal was built in Croydon in 1928, the first purpose-built one. So what was happening previously to that was being repurposed World War I building. So that original timber tower I was talking about earlier on in 1920, that's gone. But at Croydon still, you've got the new terminal went in 1928. It's Grade 2 star listed. And that terminal building and the control tower is still there. And when that was open, that was the world's biggest, most advanced airport as well. The tower was the world's biggest, and it was absolutely cutting edge at the time, bristling with all the technology they had. So that's still there. In normal times, we'd open the museum to the public on the first Sunday of every month. We give guided tours of the building, talk people through the history, show them around, and we take them up to the control tower as well. So we've got a museum there, and we've actually got reinstated his sort of 1928 air traffic control. So you can see what it was like back in the day with those big valve radios. If anyone doesn't know what a valve is, it looks a bit like a light bulb. So you've got all that there to have a look at as well.
Brilliant. We've got a question from James here. This is for you and me, Adam. It says, what are your favourite airline call signs and why? So, Adam, I'll let you go first with that one.
Wow. What's my favourite one and why? That is a very interesting question. I'm not sure I actually have a favourite one. I had a funniest one once when an aircraft was coming to Heathrow one early one morning, and it was called Jedi Knight 01. And I just heard this on the radio, and I thought, this must be a really, a Gulfstream business jet or a really posh aircraft or something like that. And it turns out to be a Robinson 22 helicopter. And I thought that was a bit incongruent there. But I don't know if you have any interesting call signs, Ady, that you've come across over the years.
Well, I think most of the people who are watching us today will probably be aware that most airlines use their company name as their call sign. So your Air France, Lufthansa, things like that. British Airways use Speedbird, which they've used for many, many years. And of course, Speedbird 1 was Concorde. So that was always pretty cool. In terms of trivia, one that I always like to ask when we're having a quiz is Egypt Air's three-letter code is MSR. And nobody can understand why that is, but if anybody can get that one, pop it in the chat and you'll get a prize. So MSR is the three-letter code for Egypt Air. Let's see who can get that one. The next question is from Alexander. Ian, at what point did radar become an integral part of commercial ATC?
Well, it's probably more for you guys, really, but it was post-Second World War, so radar really... Second World War. It was, again, we're seeing war actually develop technology, and once the war is over, of course, you can actually use that for safety purposes, peaceful purposes, to support air transport. So you had a huge development during the Second World War, and really it was post that when radar really started to come into its own for air traffic control. So up until then, it was radio. Radio was really, really important, as it still is, running up to the Second World War, but post Second World War, sort of radar was the game changer, really.
Excellent. Adam, we've got a question from Hector, who says that you spoke about the phonetic alphabet, but how do ATCOs deal with different accents? Like, Geordie.
Yeah. With great difficulty, some of us. That is a very good question, and I think that's one of the tougher things to aspects of the job as a trainee controller. When I first came to Heathrow, I found it rather difficult to listen to what the pilots were saying. They were all speaking English, and obviously the native English speaking pilots I could understand, most of them anyway, but heavily accented foreign pilots who might have English as a third or fourth or fifth language, and they might only know 100 words or so of aviation English, it can be quite difficult to tune your ear and brain into that way of talking. It just takes time to develop that ear for it, for languages. And I remember times when I was new controller at Heathrow, plugged in with an instructor next to me, a pilot would say a phrase which was standard phraseology that I should understand, and I had no idea what they just said. And I turned to the instructor, and he knew exactly. And I said, "How do you know that?" But it's just something that takes experience and to sort of tune your ear into.
Excellent. Adam, we'll stick with you because we've got Jeff from EasyJet who says, what's the greatest limitation to forecast traffic growth? That's excluding the current COVID situation in the 21st century from an ATC perspective. Is it humans, technology, or something else?
That's some cracking questions coming up here. I think I would probably say a lot of it is the ATC system airspace design. Aircraft can navigate so accurately now, but a lot of the standards, and again, some of it goes back to that global requirement of having standards that are the same across the world. What applies to Heathrow Airport with modern Airbus A350s, A320s, 777s, 787s with ultra modern navigation kit must also apply to a bush airport in Alaska with single engined, or twin engine, twin otter float planes and things like that. So having a standard across the globe can sometimes seem to restrict development, but I think the getting the airspace design right in terms of how closely you can parallel routes off between each aircraft, how close they can be together. Going back to episode 1 that you were talking about across the North Atlantic Ocean, about how the new satellite systems have increased the capacity there, almost exponentially. So it's just taking advantage of the new airborne and ground systems to enable that to sort of unlock that capacity. I think is the big challenge.
Excellent. Last question for you then, Ian. This is from Lawrence, and he talks about aircraft receiving hand signals or lights during World War II, and how soon did we really come to rely upon VHF comms to communicate?
Okay, radio is starting coming in the Second World War, but on the ground it was still visual signals, especially when you're looking at those mass formations takeoff. If we're talking about the Second World War and we're talking about those mass bombing raids, it was visual signals. Radio was used though. Once airborne, radio was used quite extensively, and I think that's well reported. If you look at Fighter Command and Battle of Britain, that was used to great effect as well to direct the fighters there as well. And even with coming on to sort of the bombers as well, long range bombers, they were used as well. We were using it quite extensively really, and I think again sort of coming out of the war, because our experience, we used it so much, we had an enormous amount of expertise with it, sort of coming out the other side of that as well. The same with Americans as well. And that's very similar to World War One. World War One, we were very much at the forefront of developing radio technology and using it and getting the experience and expertise. So coming out of that, when it came to using it in a civil commercial manner, we had all that expertise to draw on. And it was the same with the Second World War as well.
Incredible, brilliant. Well, look, to the both of you, thank you so much. I've certainly learned a hell of a lot. It's been a really, really, really interesting chat. On that question on Egypt here, MSR. The Egyptian word for Egypt is Misr, M-I-S-R. So their code is MSR. Thanks to everyone for watching. I hope that you found it as interesting as I have. And that is a wrap for episode 3 of Altitude. But we hopefully will be back next month. If you've got any feedback for us or ideas of the kind of topics that you'd like us to cover, please email us at info@nats.co.uk, or you can tweet us simply @nats. And keep an eye on NATS' social channels for details of the next episode. But from us all at Heathrow and, of course, Croydon, thank you very much for watching. Goodbye.